All right, hello everybody. Welcome to my session on analyzing source code using Roslyn. First off, let me start by appreciating that you've all come to my session. For some of you, it might be very early in the morning or very late in the evening, but still you've taken the time to join this session, of which I'm very grateful. So let's get cracked because we've got a lot of stuff to work with. My name is Erik Schierboom. I work for xUnit. I'm a .NET Foundation member, and I love learning new languages. So the image that you see is a very apt description of me. And it's also how I got to know xUnit. Most of the talk will be done in live coding, except for the first few slides, which give a little bit of a background on what is the actual issue that I'm trying to solve. So what is xUnit? xUnit.io is a website. It's a free and open source website with the aim of helping people improve fluency in a language. So if you're a C# developer and you want to become better in C#, you can do that. But if you want to learn a new language, there's also a very plausible path to take on xUnit. And that is also how I got to know it. The way that xUnit goes about helping you improve your fluency in a language is by having tiny exercises, which are like small puzzles that you need to solve. So the student downloads an exercise, and what gets downloaded is a test suite, so a set of tests. And the goal for the student is to develop an implementation that passes all the tests. The thing that sets xUnit apart from other websites is that once you're done and you have all the tests passing, you submit your solution to the website, and then a code review is done by a person that's familiar with the language. So there's an actual human being reviewing your code. So this human interaction is great at improving your skills in the language because he or she can point out all the finer details of the language. With the current version of xUnit, though, there are some issues that we have. The biggest issue that we have is that sometimes there are so many more students than there are mentors that it can take quite a while before the student gets feedback on the solution that was submitted. So that's obviously a pain point for us. Another is that if 10 students submit the exact same solution, it does require mentoring it 10 times instead of being able to mentor it once and then have it apply everywhere. And finally, xUnit is great for learning a new language, but as xUnit requires you to run things locally on your machine, it means that you have to get everything set up locally, like an SDK or possibly an IDE. So there's quite a barrier for you to get started. So that's also one issue that we have. All right, we've come up with some solutions for that. And one is that many students will have the same sort of issues with their solutions. So mentors will recognize these patterns and say, hey, this is a student that's using an if statement, but a switch would be more idiomatic. So those are all rules that are in the mentor's head. But what we try to do is encode those rules in code. And the analyzer is a tool that takes code that was submitted by a student and then looks for patterns and automatically analyze it. Similarly, another thing that we try to do is for the 10 identical solutions to come up with a way that we only have to mentor them once. And they don't have to be identical. So if they're identical, if they're not identical, but they are just different in white space, for example, or the placing of their curly braces, we could reuse the same comments. So we're trying to work with the system to have that work efficiently. And finally, as the students will be able to do in-browser coding, they won't be able to run the tests because they won't run in browser. And we have to have some way of executing them on a server. And there are some nice things that we do there too. So in this session, we'll look at how the C# track of xUnit has implemented the aforementioned tools. And for all three tools, we've used Roslyn. You probably know Roslyn as the name of the C# compiler. However, Roslyn is far more than just the C# compiler. In fact, Roslyn is the name of the .NET compiler platform. And the thing that Roslyn gives us that we are interested in is not the compiler, but it's the parsing of C# source code. So Roslyn gives us a way of taking C# source code, parsing it, and it will then return a syntax tree, which is a fully typed way of working with C# code. So we can parse C# code and then work with it in C# code. A syntax tree contains of two types of elements. The leaf nodes are syntax tokens. And tokens are just a direct mapping to a little bit of text in the source code. For example, a keyword or a string or numeric literal. And tokens have possibly trivia associated with them. And trivia are things that are ignored by the compiler, but they are in the source code, for example, white space and comments. The nodes in the tree are syntax nodes, and they correspond to language constructs. For example, classes or namespaces. So they are a bit more high-level representation, and their children will be other nodes or tokens. Okay, the best way to get a bit of a grasp of what a syntax tree is to either use Visual Studio, which has a very nice plugin that you can install. It's built in, and it allows us to give a visual representation of what a syntax tree looks like. So I've opened Visual Studio here. And if we go to View, Other Windows, and then to Syntax Visualizer, a window pops up. And if we click somewhere in the source code, it will populate this window with the syntax tree. So this is the actual Roslyn syntax tree that Visual Studio is using underneath. You can see that it has a tree structure. So there is a root node, in this case, the compilation unit. And the compilation unit's children are all the top level elements. And in this case, there are two. One is the using statement. So if I click on this using directive, it gets highlighted. And the using directive itself contains subnodes. So there is a subnode identifier name, and it has a token, the using keyword. This is a token, and it corresponds to this bit of text. This specific token also has whitespace trivia after it, so it's trailing, and it's just a single whitespace. So you can see that the tree representation is a direct mapping of your C# source code. And each node will have a class that's associated with it. So the using directive has a type using directive syntax, which is a class that we can use later on. If you don't have Visual Studio, for example, because you're working on a Mac or whatever, you have another option. It's slightly less fancy, but still nice. And that is the Roslyn Quoter, which is a website made by Kirill Osenkov. And on that website, you can enter some text, just some C# source code, and click on Get Roslyn API calls to generate this code. And then it gets a complete listing of all the different elements. It's less pretty, but it's functional, and it helps a lot instead of having to drill through all the code. Okay. So now it's time for the demo, which will be the rest of the talk. We'll be doing our demos in Rider, because that's my preferred IDE, and also to show that you don't have to do these things in Visual Studio. So let's switch to Rider. The first tool that we will be building is the analyzer. And the analyzer is the tool that encodes the rules that the mentor had in his head or her head. So it's just a regular .NET Core tool. So nothing fancy there. And the student has worked on an exercise, and that exercise contains of 2 bits of code. So there are the tests, and there are only 2, because the functionality that the student is expected to implement is a greeting method that can be called either without any parameters, in which case hello you exclamation mark is returned, or it can be called with a name parameter, in which case hello name exclamation mark is returned. So very simple. The solution that the student came up with and submitted is this one. It uses method overloading and a little bit of string concatenation. So it looks okay, but let's see if we can build a little bit of logic in our analyzer to guide the student towards a somewhat more concise and hopefully more idiomatic solution. So to do so, I've stepped 2 things already, which one is the path to the file of the student, the exercise file, and the other is reading that file into a string. So the first thing that we need to do is, well, we want to use Roslyn's C# parsing functionality. So we need to install a NuGet package. And the package that we need to install is microsoft.codeanalysis.c#. So let's install that into our local project. Great. And then we are ready to parse C# source code. So the way that you do that is you do C# syntax tree dot parse text, and then you can parse it. Yeah, there are many overloads, but for now we'll just parse the text that we just that we had already stubbed, and this will return a syntax tree. So we'll call that tree. The tree itself is nice and it has lots of properties, but we are mostly interested in the tree nodes because the tree nodes contain the actual source code structure. So there's one thing that we also need to do, which is to get at the root. So we'll call that root, and let's debug this and see what the root is. Right, 1, 2, 3. Here we go. So let's go over this one, and we can see here that the root is of type compilation unit syntax. And as you might recall, that's the exact same node that we saw in the Visual Studio syntax visualizer. So that's nice. We now have access to the C# source code. We won't go into all the properties, but we'll be discovering them while we're developing the analyzers. So what should we have as a rule? So one thing that I don't like about this is that it uses method overloading, whereas it could be using a default parameter. So let's try and build an analyzer for that. So if it uses method overloading, and then we'll pass in the root, we'll write out, please use an optional parameter instead of method overloaded. Let's remove the stub and create the method. All right, so we have the root. So how do we detect if method overloading is used? At this point, it's usually good to have a real firm grasp in your head of what the syntax looks like in the tree. So one thing that we can do is we can parse this code, put it here, and then we can see that it's a method declaration. And the type of the method declaration is method declaration syntax. All right, and we can use that. So the way that we do that is that we can ask the root for all of its children, so all of its nodes. And then we can filter those nodes on a type. So in this case, it's a method declaration syntax. So the result of this will be all the children that are of this specific type. And then we can do a count of all the methods where the identifier, and the identifier is the bit of the tree that describes the name. It has a text property, and this is just the method name. So this will return all the number of the count of the number of methods where the name is equal to greeting. If that is greater than 1, method overloading must be used. So if we run this again, we should get a comment that the student uses method overloading, but that an optional parameter can be used. And indeed, that's what we see here. So we got a first analyzer, relatively quick. At this point, the student will get a message that there was a comment from a mentor or from an automated analyzer. And usually the student then fixes the issue. So the way this student decided to fix it is by making the name parameter optional and adding the null as the default value, and then adding this check. So this becomes like this, and student moved this to here. And this removes the method overloading bit. So running it again would not trigger the method again, the message. All right, nice. So the second thing that I would suggest to the student here is that instead of using null, the default value is actually u. So it's a string literal that you can use. So if uses null as default value, let's output another message. Please use a string literal as the default value. And let's see how we can detect that. We know at this point I could be doing a return here, but I won't just for brevity, that the method has a greeting method because we are guaranteed that before this analyzer runs, all the tests are passing. So we can make some assumptions there. And the beginning is thus very similar. We'll look for the greeting method. So once again, we find all the methods, and then we find the one method which name, method.identifier.text equals greeting. So this finds the one method declaration that has the name greeting. So let's call this greeting method. As said, we are interested in looking at the default value. So what we can do is we can go back to the syntax visualizer, but we can also start by just looking at the properties of the class. And there are lots of things here. Some of them you will probably recognize, like body or expression body, but there's also a parameter list. And we're interested in parameters, so let's look into that property. It itself has the opening and the closing parentheses, but it also has parameters. And we can get access by them by index. So this is the first parameter. And then what's there? Hey, there's a default, and it is of type equals value clause syntax. Oh, now things are getting a little bit complex. So what we can do is we can parse this back here and see what the representation is of the name equals null bit. So we have a parameter. This is the equals value clause. Hey, and this is a null literal expression. This looks like the thing that we're looking for. Its type is a literal expression syntax. So what this means is you don't just have null literal expressions, you can also have string literal expressions, etc. And they are described by the same class. The way that you can differentiate between them is by looking at their kind. And the kind is just a big enum with all the different options. So we have to check if it's a literal expression syntax where the kind is a null literal expression. So let's do that. We can go back. So we can do if the default is a literal expression syntax, and we'll assign it to the value literal, and the literal kind is equal to syntax kind dot null literal expression, then it must be using as its parameters default value, dot value, a null literal expression. So if we run this, the second case should hit it. So let's see that. All right, please use a string literal as a default value. All right, we're being a good citizen again, and we'll just do this. And already the student is really happy because it's starting to look very nice and concise. And usually my next point would be to look into using string interpolation, because I personally really like it, and I think it makes it a little bit more concise. If does not use string interpolation, please use string interpolation to format the return string. All right. We'll do a little bit of copy pasting here. We won't do any refactoring or whatever. We can do that later if we would like that. And we'll grab the same method reference. And now what we want is to see if any of the, we can make this as fancy as we would like, but we'll do a very simple check. We'll just check any of its descendant nodes, so any of the children of the method, so any of its statements, is of type, and then we have to find out the type. We could go back to the syntax visualizer or to the Roslyn quoter, but you can also just try, what if I just do interpolated? Oh, there are several. You can try. You can just also debug and see what the descendant nodes are. In this case, I know it's an interpolated string expression syntax. It's a long name. And if there are not any, so this method returns true if there aren't any nodes in the tree, in the tree of the greeting method, which itself is a subtree, that have the type interpolated string, it will return true. So if we run this, it won't detect any of the string interpolation types because there aren't any, and it will return the message. So fixing this, we can do it really easily because there is a built-in conversion, or like this, and this fixes the issue. Yep. And oh, didn't I save? Oh, I did the wrong thing. Sorry there. I meant to do this. So there was a little spoiler for the next session. All right. Yeah, and it works. So I should probably have guessed. The final thing that I would like to detect is using an expression body, because I really like it. It's a single line method. Not everybody likes them. If can use expression body. So I'll be a little bit gentle in my message. So consider using an expression body. This is, I found that people get really religious about this. So I'll try and make it a suggestion more than the rest. So let's copy paste this again. And then we can just drill into the properties again and see what it looks like. So tons of properties here. The thing that we are interested in is either a body or an expression body. And the way that Roslyn works is that a method can have either curly braces and then the body is set and expression body is null, or it can be an expression body and expression body is set and body is null. So in this case, what we want to check if the body is not null, so it has a body. And if you might recall, expression bodies only are allowed when there is a single statement. So let's see what we can do there. And the thing that I'm trying to get across is that just by dotting into the classes and the instance of the class, you are probably really getting along with the tree. So there is a statements list, and we can just do if the count equals 1. And this speaks to how well designed Roslyn is, because I find this relatively intuitive. Body.statements.count. This almost reads like prose. So let's run it. It's also good that it's very nicely designed, because the documentation can sometimes be a little bit lagging. And now let's use this refactoring and run it again. And we shouldn't have any comments. All right, so with relatively little code, there's a lot of duplication here that we could eliminate. We were able to guide the students from a solution that used 10-ish, 12-ish lines to a single line solution that I think is really pretty and concise. We can apply this to more complex scenarios too, but for this case, something relatively easy would also be very helpful to us, and that mentors wouldn't have to comment on them again. So this is the first tool that we've done. So I'm going to unload this project and move on to the next one. And the next tool is the representer. And the goal of the representer is to take a student's solution and to somehow create a representation of it that, and we can then look at the representation to compare solutions. So if 10 solutions that are identical, they should have the identical representation. And if 10 solutions are almost identical, for example, they're only different in white space, they should still have the same representation. And this will allow us to comment on the representation once and then have it applied to all the solutions. So this is a big win for us. The way this exercise works is it's slightly different. It's a test about a leap year. We're not really interested in the test now, so let's just open the solution that the students submitted. So this is the solution. It's a completely working solution. It passes all the tests. Only the formatting is a bit inconsistent. So there are 2 spaces here. There are lots of empty lines here. The curly brace is on the same line here, the opening is on the new line here. So lots of things here that if we didn't do anything about the code would mean that they won't be equal. So the representer is very similar to the analyzer at its core. So we have the same package reference, and it's also just a console application. And I've stepped out a little bit, and it's the same basically as the previous one, where I read the contents of the implementation file. So that's the exercise, and I parse it to a tree and get its root. So we have the root here. And the next step we have is to somehow write this to a representation. A representation you can think of also as a hash. So I have a path Representation is a single file. We'll just name it representation.txt. So how do we put our root into the file? Well, as it turns out, Roslyn has a really interesting and nice feature where it not only allows you to parse C# source code to an in-memory representation of that, but it can also convert back to source code. So any node you have in your tree, you can convert back to C# source code. Not every compiler does this, but Roslyn does, and it's really nice, and I can show you how it works by doing file.write.text, representation file. So we'll write into the file, and it will be here in a minute. And then what we can do is we have the root node, and the root node is a syntax node of type compilation unit syntax, although we don't care about that. And if we do toString, it's basically a back and forth. So we're now parsing it to Roslyn's representation and back to source code. And if we run this application, we should be seeing a representation created here. And we do. And you are probably not surprised that if I open this, it is the exact same contents except for the IDE hints as the source, because we didn't do anything. But this in itself is already really useful. And this is also why Roslyn stores the trivia, the white space, etc. Because many syntax trees for other languages don't include the trivia. And that means that you can't go back to where you're from because you're losing knowledge. So let's try and fix some things about the representation, try and normalize it. So the first thing that I would like to do is, because I'm OCD, I would really like to normalize everything. So white space usage, etc., placing of curly braces. And you might be thinking that this could be the rest of the talk, but you've been mistaken, because it's just a single method call. On any syntax node, you can call normalize white space, and let's just run it and see what it does to our representation. Isn't that great? So with just a single method call, Roslyn was able to normalize the code according to its built-in standards, coding styles. So already it's looking much better. The next thing that I would like to remove from the representation is the using statements. Students could have open using statements that are unused, etc. And normally we are not in the habit of commenting on using statements. And we already know that the solution passes the test, so it's all good. Let's just remove them from the representation. How would we go about doing it? Well, what we can do is there is a property on the root that's called remove nodes. And then we pass in an enumerable of nodes. So we can reuse what we just learned about having a descended nodes property and then filtering by type. The type of a using statement, let's just do a quick. Let's put this here. Whoops, sorry. So let's put this here, save it, and then dig into this a little bit. So we can see that it's a using directive and the class is using directive syntax. Okay, so going back, it has the type using directive syntax. And then we have to supply a second parameter. And there are many options here, which I won't bother you with, but let's just do the first one because it works well. And let's run it and see what happens to our representation. Oh, nothing happened. So why is that? This is actually expected. So one really interesting property of Roslyn is that it's completely immutable. The whole tree, every node is immutable, which means that once a tree is created, it can never mutate. It's immutable. You cannot change things except by creating a new tree with modifications. So removing the nodes did remove nodes, but it didn't remove them in the source. It actually returned a new tree. So if we call the new tree representation and then use that to write out our code again, then we shall be seeing results. So this is a very important property in Roslyn that you should really be aware of. You cannot just mutate bits of the tree. You have to create a new instance of the tree. And the reason for this is for concurrency issues mostly, because if everything's immutable, you don't have locking because you can't have multiple threads accessing the same nodes at the same time, which makes it great for the IDE itself, because it will be doing things in the background, etc. So it's really tough to implement. You have to be very diligent about it, but the end result is something that's really nice, and the performance is also still good. So something that's immutable doesn't have to be bad performing, but it's something that you always have to keep in mind when working with Roslyn and syntax trees. They are immutable. All right. So while this works, there is a nicer way to do these. I want to modify some parts of the syntax tree functionality. So the way that you can also do this is by having a class, and we'll call it remove usings, and have it inherit from C# syntax rewriter. So the idea of the C# syntax rewriter is that for every type of node or token that you have in the tree, you have a method that you can override, and you can basically say, hey, I want to do something special with this node or token. And the C# syntax rewriter will automatically visit the tree in the right order, etc. It will do all sorts of things from you and will return the correct tree. So this example we can rewrite as follows. So we start with overriding. That's always the case with the C# syntax rewriter. And then it's visit, and then it's the type of the syntax node. Now, we were using a using directive. So we'll override this method. And instead of doing just the built-in functionality, we can return null. And you can see that the syntax node is nullable. So if we do new remove usings, and then you do visit. So you can call tons of methods if you have a specific node, but we now have the root node, which is just of type syntax node. So if we pass in the root here, we get back a new root node with the updated representation. So let's run this again, and it should still remove the usings. And it works. That's nice. Personally, I really like this feature. It's a little bit more code now, but if you try to do more complex things, this method really shines. And let's try to do some more. And we'll use this method for the rest of the case. One obvious thing to remove are the comments. So we have XML documentation code, we have multi-line comments and single-line comments. So let's do class remove comments and also have it inherit from the syntax rewriter. And if you remember from the slides, comments are things that are not compiled. So they're only there in the source code, but not for compilation purposes. And everything that's not for compilation purposes, like whitespace and comments, is named trivia. So what we can do is we can override visit trivia. We can't just return null because, well, for two reasons. Syntax trivia is a struct, so we can't return null. And if it was, we would also be removing all of the white space, which I don't want. I'll just want to remove the syntax of the comments. So what we can do is trivia.isKind. This is a syntax token, and they also have the kind property that we saw before. So we can do syntax kind, and then we can just do comments, and we find several things. Let's try single line comment trivia. And if that is the case, well, we can't return null, but we can return just default. And here we can do base.visit trivia. And this will just do the regular functionality. We only have a special case for the single line comments. So we'll just duplicate this line, add the call to the remove methods, rewriter, run it again, and we should be seeing that this single line comment is removed. And like that, it's gone. So adding the others is very simple, and you've probably already guessed parts of it. So this is a multi-line comment trivia, and there is also single line documentation comment trivia. So it's quite verbose, but it does specify well what it's doing. So run it again, and we'll get rid of all the comments. All right, very nice. Another thing that struck me when I looked at this code was that some of the variables are defined using the var keyword and others just by the type. So what we can do is we can just use var everywhere. So let's try that. I'm a huge var fan too, so that suits my purposes. Use var as type. In this case, it might be useful to see what is the syntax for variables. Oh, sorry, that was the wrong. And we'll go here and we'll click on the bool and examine what its tree looks like. So bool is part of the variable declaration, and the variable declaration is of type variable declaration syntax. All right, so we can work with that. The difference between a bool, the var declaration, and a var is that for a var, the type is an identifier name, and the identifier name is just a bit of string, in this case, var. So let's see if we can work with that. Go back to our rewriter, override variable declaration, and then we'll look at the node dot and type. So you might be thinking, hey, let's do node.type equals and then do something. So we can't do that because, well, Roslyn is immutable. So there is no way to set a property on the node. So for everything that you can modify, Roslyn has withers. So there are methods that's starting with and then the property that you can modify. So there is a way that we can change the node and have it use a different type. All right, so we can pass in a type syntax there. You might be thinking, oh, sorry. So you might be thinking, how can we create that? And it's actually not done by just doing this, just newing up things. So what you do is there is a syntax factory, and the syntax factory is just a static class with many properties, and there are types everywhere. So let's just to see what it looks like, do a little debugging. Just to give you an idea of what all the properties are. So variable declaration syntax, and you can see here that the toString method also works on individual nodes. So this is a nice way of declaring the Boolean. And there are many properties. And we can see here that there's the type, which is the predefined type syntax. And if we continue, the type is, whoops, where is the type? Yeah, the type is here. And now it's an identifier name syntax. So that's the one we want. So the type should be identifier name syntax. So with type syntax factory dot identifier name, and then we can just pass in the string. So just to make it very clear what's happening, this is a new variable declaration type. So we basically create a copy of the existing one and then have one property modified. In this case, the type property is modified to the identifier name. And if we now run this, we should be changing our Boolean variable to a var. Yep. All right, so I guess I have a slight mistake here. Let's fix that. My bad. Easy fix. And now the comment should be removed and the var is all right. Yeah, so this is nice. Let's look at another thing that we can do. This if statement uses curly braces, and this statement doesn't. So functionality-wise, there is no difference, but syntax-wise, it will result in two different representations for us if we just output this. So let's add curly braces if there aren't any. So we're doing that with another rewriter. Add braces to if or else statements. Make it C# syntax rewriter. And well, let's just do visit if. And there are just a couple of matches. So usually this is just enough to figure out where you got to go. And then let's see what we can do. So if we go back to Visual Studio and we'll look at what the format is of this if statement. So this is an if statement and it has a block. And if we go back here, we can see that the block itself is the bit between curly braces. And if we go to here, we can see it doesn't have a block. It's just directly a return statement. So we check for the node. And if you don't know which property, you can also do with, just to get a grasp of the things that you can change. And in this case, it's not the condition because that's the Boolean part. It is the statement. So if the statement is a block syntax, that means it's an if statement that already has the curly braces. We can just continue. In the other case, it doesn't have block statements. So how can we add those? Well, we can modify it directly, so we have to use one of the with methods. We can do with statement, and we want to basically wrap the existing statement in a block. So we do syntax factory dot block, and the block can take any statement. So we can pass the existing node's statement. So we're basically wrapping the existing statement in a block and then using that as the statement for the new node. And let's see what that looks like. And we should be seeing something here. And now it has braces. So you can see very little code for things that might look complex. Let's do the else just to get it out of the way and to show you that Roslyn is really well designed and it has lots of symmetry where you expect it to be. So we use the exact same code. Roslyn doesn't go overboard with inheritance. So many things that you might think are inheriting from each other aren't, which is a good thing, I feel. So in this case, the else clause doesn't have anything to do with the if statement except for some very higher base class. And you just have to do a bit of code of copying, but that works nicely, I think. Right. And the else is added too. So let me be very quick for the last one. So one obvious thing that we found that students do is change variable names or parameter names. So if we supply them with the year parameter, they might rename it. But renaming the parameter doesn't have any influence on the actual representation because it's the exact same code except for the name. So let's see if we can normalize that. Normalize identifiers. And this time we need a little bit of state. So what we want is that each time we have a parameter definition, we have to do something with it. So let's start with overriding the visit parameter method. A parameter has an identifier property, which is the name of the parameter, and that has a text property. So let's keep track of use a dictionary of string that maps the old identifier, so the original parameter name, and maps it to a normalized one. Call this mapping dictionary. So we can do mapping.try add and then copy in the original name of the parameter. And then as the new value, we can do something like identifier and just, well, make it easy and do the number of existing ones in it. And then we can, this doesn't really do anything except keep track of it. And so we want to modify the parameter itself too. So we can do node with identifier and then do syntax factory dot identifier name. And then pass in, oh, this is not an identifier name, this is an identifier. And then we have to do mapping. So basically what we're getting here is the new version of the parameter name, the normalized one, which is equal to this. So if we run this, and we have to add it here. Let's see what the representation does. And it has changed the parameter. Well, this doesn't really do much, except now we didn't change the actual usage of the parameter. So we have to change that too. And the way we can do that is by overriding anytime an identifier is found, visit identifier name. So we can then do mapping.try get value to see if there is a mapped identifier for this identifier's name. And if there is, we can output it in the mapped identifier property and return node dot with identifier and do syntax factory dot identifier name map property. Same mistake, sorry. So this is now the ordering is really important because the parameter is visited first, and this parameter has an identifier in it. So it's really important that the C# syntax rewriter first calls visit parameter and then calls visit identifier name, which it all handles for us. And that being built in, I don't have to do anything with it. So let's run it. All right, and that now completely makes the normalized identifier the one that's used inside the method. And it would be trivial to add it to the class declaration and whatever. So, but I'm running out of time a little bit, so let's just do that later if somebody would like to see that. And let's move on to the last one, the last two. So that is the test runner. The test runner has two projects. It has the test runner itself, and it has a student solution. The student solution is the same as the previous one, just has a lot of tests and an implementation that passes the test, which is admittedly much nicer than the previous one. I'm going to unload this project and I'm going to remove its bin object directories because Rider will have done some magic in the background already. And we don't want that. And I'll show you later why. So the test runner, it will be different from the previous tools because now we will be working with a project because we want to run all the tests that are in a project. And the goal of the test runner is to take a student solution and have it run against the test suite and then detect if there are failing or passing tests. And for the failing and the passing tests, write out a JSON report. So we could have done .NET test and parsing the text output, but I don't like parsing text output because it's, well, brittle. And because it might be cool to do something like in-memory stuff, I wanted to try and do this all with some NuGet packages instead of doing just shelling out to the CLI. So the first thing that we need is we need some NuGet packages. So what we need is instead of using Microsoft.codeanalysis.c#, we need Microsoft.codeanalysis.c#.workspaces. And this bit is required to be able to work with CSproj files. It's not enough though, because we also need the msbuild, codeanalysis.workspace.msbuild package. And the combination of those two will allow us to work with CSproj files. So let's get started. First thing to do, I have a reference to the exercises project file, and we have to create a workspace. And a workspace is like an environment where you can keep track of your solutions and your projects, etc. So when you're working with projects and solutions, you always create a workspace first. The workspace has a method that's called openProjectAsync, and we can pass it a path to a project file. So I had that already stubbed out, and we can then await it, and this will be a project representation. So this is an in-memory representation of what the project file looks like. Let's just run this and see what happens. It does compile, so that's good. Whoops, we got an exception. Could not load file or assembly Microsoft.build. The thing here is that when working with the msbuild workspace NuGet package, it will under the hood use msbuild. And for different versions of the .NET framework or .NET Core, there will be in different OSs, there will be different places where msbuild is located. So there is a package that you can use. It's called Microsoft.build.locator. Let's install it. And its sole purpose is to somehow make it known where msbuild is located. So you do msbuild locator.register defaults. You have to make sure that you call that before the first call to an msbuild API method. And let's run it and debug it to see if it now works. And indeed, we now don't have an error, so hooray. Let's see what the project looks like. So there are many properties here. One of them that's important to us is documents. So it contains all the files that are in the project. In this case, we have two, a test file and an implementation file. So let's stop that. We'll remove this message. Next step is how do we run xUnit in memory? For that, we need another two packages. The first one is just a regular xUnit package. So let's install that. And the second one that we need is something that's called, in xUnit terms, a runner. It's found in xUnit.runner.utility. And the runner is something that is able to run the tests. So let's install those. And then we have access to a type that's called the assembly runner. So one thing that we can do is the assembly runner. Sorry, I did the wrong thing. So assembly runner, we have to create it like this, sorry. It has to be passed in an assembly file name, and we don't yet have an assembly. We do have a project though, and projects can be compiled to assembly. So how do we get from a project to an assembly? To do that, the first thing that you need to do is you have to get the project's compilation. So var compilation equals get compilation async. And a compilation is an in-memory representation of, well, an assembly or something that you can compile. It isn't compiled yet, it's just a representation. And when working with compilation, the first thing that you should always do is check its diagnostics. So the diagnostics are the things that you will be seeing if you do a build, warnings, errors, etc. So let's do a little bit digging on to see if there are any errors. So diag.severity equals error, and this will be errors. So the first thing I did is get the diagnostics, and then I filtered them where the severity is error. And let's output the number of errors and see if everything works well. Errors.count. Let's run it. And let's see if that's working nicely. Whoops, 123 errors. Ouch. So one thing that we can do is see just what the errors are, because, well, we have an in-memory representation of those. So errors, let's see what they are. A little bit of waiting, and whoa. Predefined type system object is not defined or imported. How can we fix that? And what is the issue here? Well, the issue is actually that we didn't do a .NET restore. And .NET restore has some properties that it creates a file that contains all the assemblies that need to be loaded. And this is also why I unloaded the project, because if I didn't do it right, I would have done it in the background. So one thing to do to fix that is to do process.start. And we'll just shell out to the .NET CLI here. And we'll do .NET restore and then do the project file path. So this will do a restore in the background, and we'll wait for it to exit. Run it again, see how many errors we have. Hopefully less. And no, we actually have more. How is that possible? So it turns out that this is actually a bug that I found out last week. And the thing is that we are missing an assembly reference. And the assembly reference is not automatically added, but we can add it manually. It's called NuGet.project model. And if we install that into our project and then run it again, we should be having a errorless compilation. Fingers crossed. Hooray. So now what we did is actually, we are doing .NET build in memory. We still aren't there what we want to be because the assembly runner needs an assembly file name. So how can we have a compilation output an assembly file? And that's actually very easy. There is an emit method, and that emit method takes lots of overloads, but one of them is just the file path. And we could hard code it, testrunner.dll or whatever. But there is also a nice property, compilation.sourceModule.name, that contains the DLL name as the project would be output. So this will output the DLL to this location, and then we can create this assembly runner. So now we're almost ready to really run the test. So let's see what the assembly runner has for its properties. It has tons of callbacks, actions. And the thing that we are interested in is whether the test is passing or failing. So we can do a little console logging here, and we'll just do this is a failing test, and then output the test display name. So you can see here that the properties of the info callback parameter are matching them of the domain of xUnit. So this is really an xUnit internal specification. So let's use that, and just to have us be complete, also add callbacks for the other two possible statuses that xUnit supports, which are skipping and passing tests. And then finally, let's see if we can run the assembly runner, not array segment. And there is a method, and that method is called start. All right, so let's run this and see what it does. No errors, good. But there's also no output. So this is weird. It took me a little time, but if you go to the documentation of start, it says this call returns immediately. So it doesn't wait for the test to finish. There is a callback on execution completed. So, but what can we do here? The xUnit documentation suggests using what's called a manual reset event link. And you can sort of see this as a flag. So we call this finished. And when it starts, it has a flag down. So you can actually you can pass it, but you have a method that makes the flag go up. And if you do finish.wait, it will wait for the flag to go up. And initially it won't be. Once the execution is complete and we get here, we can just set the flag and it will go up, and this blocking call will then continue. So let's run it again. All right, it doesn't work, and it doesn't work because there's an issue with loading the assembly. And the way this is working is that xUnit will try to look for the assembly in the current assembly load context, and our dynamically compiled executable isn't in that. And the fix is relatively easy. We can load the assembly and just use this name and then run it again. Let's do it very quickly because I'm running out of time. And all right, it now actually ran all the tests in memory, and we got our callbacks called. So it does say skip a lot, and that's because our tests are, except for the first one, all marked with skip. And this is because we want to encourage TDD, where students solve a bit of the implementation one at a time. And let's see if we can fix that, because we now have syntax, the test runner syntax, and we can do something with it. First, let us grab hold of project.documents. So these are all the documents that are in the project, and we do single doc.name equals test runner exercise test.cs. So this is our document, and for the document we can get its syntax root as This is a different way of getting the syntax root instead of calling the parse method. So we now have the root of the test. And we can just write a syntax rewriter that we just did. So unskip test. I'm going to make this a bit quick because I'm running out of time. We'll override the visit attribute because we are interested in the fact attribute. We can check that by doing node.name.toString equals fact. And we can then we have to modify the node. So we can do a wither. And we can say that it's argument list. We don't want any arguments. So we're effectively removing the skip bit. And then we can apply that to our root. So visit root. We'll just reassign it for the moment. This doesn't do anything yet because remember, everything is immutable. So this will return a new root and the document won't be updated. But what we can do is we can do document dot with syntax root. And again, not only the syntax trees are immutable, the documents are too. So let's reassign the document. And to make things even stress it a little bit more, this won't work actually. So let's run it and see that this doesn't do anything except for running the test as it did previously. And I'll already explain why, because the document.with syntax root returned not only a new document, but it also returned a new project. So everything is immutable, including the project. And the fix is easy. We'll just reference the project from the document. And now we run it. It should all work. And now it's all passing. So we used Roslyn to get everything working. And we did a little bit of the syntax rewriting, etc. I have a different version where I don't write to an assembly, but it's relatively involved. So I didn't have any time to incorporate this into the slide, but it will be in the source code. So that's the demo. I want to thank you all for coming. I really enjoyed doing this. The slides are all up, the source codes too. If you like xSystem, go to the website, xsystem.io. If you want to help us build these kinds of tooling or for other languages, go to github.com/xsystem/v3. And I don't know if we have any time for a question because it's quite late. But if not, thank you very much and hope to see you again a different time.
Hi, Erik.
So let me put on my earplugs.
Sorry.
All right.
Do you hear me?
Yeah, I can hear you.
Yeah. I think it's a lot of questions on the Slack channel, so you might want to scoot over there and answer people.
All right.
Or you kind of have a 5 minutes, 7 minutes.
All right.
Yeah. So if you are able to answer those questions by then.
Oh, yeah. All right. I'm seeing some message about using LinkPad for syntax visualizing, which is really helpful. LinkPad is a really nice tool. So thanks for that, Richard. Can we get the hands on the source code? Yeah. So I'll post it in the reply soon. So that source code will have a master branch that contains all the source code that I just built. It also contains an initial branch if you want to build it all yourself to see if you can work it out yourselves. And there is something with xUnit that does everything completely in memory if you like that. Guillermo Ferreira asks if MS Build Workspace is available on a non-Windows runtime, and it is. This used to be a real issue. It used to even not be possible to do this on .NET Core. It was tied to .NET Framework, but over the last year or so, it has been made fully open source. So I actually developed most of this tooling on my Mac machine. So yes, it is fully non-Windows supported. Source code will be great. We'll be doing. Have you tried to run tests in memory loading the assembly to assembly load context? Yes, I tried to do that, and you can definitely do that, but it was a little bit much to do this in this presentation. Per Oivits asked, the example that used if and else statements, would if statements be nested? No, I don't think so. I'm not sure if I completely understand what's saying, but we can go into that later, perhaps. Thomas, thank you for the compliments. Also a call for the source code. Yeah, definitely. Everything that I do is open source, so I'll put it up for you. Stala says, I can't think of anything I can use this for, but it was really cool. I'll take that as a huge compliment. We're all programmers, so it's just fun to play with this. And I started playing with this before I actually thought of a use case. So maybe getting started with this then leads to possible use cases later on. Sarah says, thanks, that was useful. Okay, thank you very much. Justin says the same. Oh, somebody has already found the link to the source code. So yeah, if you want to find me on the interwebs, I'm always named the same, just Erik Schierboom, just my name, my Twitter, my LinkedIn, my GitHub. It's really easy. Thanks for the possibility with Roslyn. My pleasure. My pleasure. Everybody's doing lots of things that I really enjoy seeing. Everybody's really happy. Cool presentation, interesting topic. All right, brilliant. Let me see, there's also some in the chat. Somebody says there are checkered parts in the window, probably to hiding something. Oh, sorry. Usings are back, you're correct. It was a little bit of a coding mistake from myself. Our else if statements are separate type or will it be braced? They are a separate type, else's and ifs. So there was one of the points that I tried to make is that you might be thinking that it would be an if else statement, but it's actually an if statement that has an else clause. And the else clause is a different type again. So almost every little bit of syntax that you have has a special dedicated class for them. All right, Simona says, great work at xSystem and with this presentation. Thank you. Some people are talking, so I'll just wait. I think, yeah, I can grab a link to the source code in between. Oops, let's move this here. GitHub. So I'll just post it again, just to make sure that everybody. All right, thank you, Guillermo. It's great to see so many people show up. I was a little bit anxious that people might think, Roslyn, that's just a compiler. How can it ever be interesting? But apparently people found it interesting, so great to hear. Right, you're welcome, Terge. I'm not sure if I pronounced that correctly, but well, I'm just Dutch, so. All right, I don't see anybody typing again. Oh, Dutch, dankjewel. Graag gedaan. Leuk dat je er was. That was for us Dutchies, sorry. For the rest, just saying thank you in Dutch.